Hi guys, we have learned from the previous video that syntax analyzer follow production rules, defined by means of context grammar, and the way these are implemented divides parsing into two types, top-down and bottom-up. In this video, we will talk about top-down parsing. Top-down parsing technique parses the input and start constructing a parse tree from the root node, gradually moving down to the leaf node. Top-down parsing can be recursive descent, which is parsing technique that construct the parse trees from the top and the input is read from left to right. Which is parsing technique that construct the parse tree from the top and the input is read from the left to right. It uses procedures for every terminal and non-terminal entity. And this parsing technique can be either backtracking or non-backtracking. But the grammar associated with it cannot avoid backtracking. If the recursive descent parsing does not require backtracking, it is known as predictive parsing. To understand top-down parsing technique that requires backtracking even more, let's use this example. For an input string, read a top-down parser will behave like this. It will start with S from the production rules and will match its yield to the leftmost letter of the input. The very production of S to RxD matches with it. So the top-down parser advances to the next input letter. The parser tries to expand non-terminal and to check its production from the left, X to OA. It does not match with the next input symbol, so the top-down parser backtracks to obtain the next production rule of X to EA. Now the parser matches all the input letters in the ordered manner. The string is accepted. On the other hand, predictive parser has the capability to predict which production is to be used to replace the input string. Thus, it cannot suffer from backtracking. Before we tackle about predictive parsing, we should know about LLK grammar. LL grammar is a subset of context-free grammar but with some restriction to get the simplified version. In order to achieve easy implementation, LL grammar can be implemented by means of both algorithms, namely recursive descent or table-driven. LL parser is denoted as LLK. The first L in LLK is parsing that input from left to right. The second L in LLK stands from leftmost derivation, and the K itself represents the number of the look-aheads. LL parser is denoted as LLK. The first L in LLK is parsing that input from left to right. The second L in LLK stands from leftmost derivation, and the K itself represents the number of the look-aheads. Generation. Generally, K equal to 1, so LLK may also be written as LL1. To accomplish its task, the predictive parser uses a look-ahead pointer, which points to the next input symbols. To make the parser backtracking free, the predictive parser puts some constraint on the grammar and only accepts LLK grammar. Predictive parsing uses a stack in a parsing table to parse the input and generate a parse tree. Both the stack and the input contains an end symbol $sign to denote that the stack is empty and the input is consumed. The parser refers to the parsing table to take any decision on the input and stack element combination. To sum it up, in recursive descent parsing, The parser may have more than one production to choose from a single instance of input, whereas a productive parser, each step has at the most one production to choose. There might be instances where there is no production matching the input string, making the parsing procedure to fail.